Do parallel universes exist? The multiverse explained. What if every choice you ever made created a different version of reality? What if right now, there's another you living a completely different life? This might sound like science fiction, but it's a concept that extends far beyond mere imagination. Welcome to Cosmic Enigma. Today, we're diving into one of the most mind-bending ideas in modern physics, the multiverse theory. It's the notion that our universe, with its trillions of galaxies and billions of stars, might just be one tiny speck in an unimaginably larger collection of universes. This isn't merely a fun thought experiment. It's a serious hypothesis explored by leading physicists to solve some of the biggest puzzles in cosmology. So what exactly is the multiverse? Simply put, it's the hypothetical set of all universes. This grand collection is presumed to comprise everything that exists, all of space, time, matter, energy, information, and even the fundamental physical laws that govern them. The individual universes within this vast grouping are often called parallel universes. Our observable universe, as immense as it is, could be only a fraction of a much larger multiverse, an assemblage of universes dizzying in its extent. It's a concept that currently exists outside our current scientific understanding of reality, but theoretical physics suggests it's a very real possibility. Scientists have proposed several fascinating models for how a multiverse might exist. One prominent idea is the many worlds interpretation, MWI, of quantum mechanics. This theory posits that every time a quantum event occurs with different possible outcomes, all of those outcomes are realized, each in a different, newly created parallel world. This implies that the universe constantly splits into multiple coexisting realities. This elegantly solves paradoxes like Schrödinger's cat, where the cat is both alive and dead until observed. In MWI, when you open the box, reality splits. In one universe, the cat is alive. In another, it's dead, and you only experience one outcome. Some theorists even suggest that quantum computers leverage this by performing calculations simultaneously across multiple parallel universes. Another leading theory is the inflationary multiverse, which arises from the theory of cosmic inflation, a period of exceedingly quick expansion in the very early universe. Physicists suggest that if inflation is the natural state of the universe, it could continue indefinitely in vast regions of space. Within this eternally inflating expanse, countless bubbles of normal space can spontaneously form and cool down, each becoming a distinct universe. Our universe is simply one such bubble. Crucially, these bubble universes can have different fundamental laws and constants, leading to vastly different realities. Physicist Max Tegmark systematically categorizes multiverses into 4 levels, increasing in their speculative nature. Level 1 suggests that if space is infinite and uniform, then identical copies of our universe must exist far, far away, simply beyond our observable reach. Level 2 encompasses the bubble universes from the inflationary theory, where quantum fluctuations during their creation lead to different physical laws. Level 3 is the many worlds interpretation, where every quantum event branches reality. Finally, level 4 is the most abstract, suggesting that all possible mathematical structures exist as physical realities, meaning universes with fundamentally different laws of physics. M-theory and Brane cosmology offer another perspective. M-theory is a theoretical framework that aims to unify all versions of superstring theory, suggesting the existence of 11 space-time dimensions. In the Brane world scenario, our familiar 3D universe is posited to exist on a 3-dimensional brane, which floats within a higher dimensional expanse. This expanse could be populated by other branes, representing other parallel universes. This theory even offers a speculative explanation for why gravity is so weak in our universe. Gravitons, the hypothetical particles mediating the gravitational force, might leak off the brane into these extra dimensions. So why do scientists even consider such wild ideas? One compelling reason is to solve cosmic fine-tuning. Our universe's fundamental constants, like the strength of gravity, appear incredibly precise, as if fine-tuned for the existence of conscious life. The anthropic principle suggests that if countless universes exist, each with different constants, it's no surprise we find ourselves in one that supports life. We are here because our universe is like this. The multiverse also offers a resolution to quantum paradoxes, as seen with Schrödinger's cat, by simply stating that all possibilities happen in different realities, removing the need for a mysterious collapse. Furthermore, the implications of an infinite universe suggest that if space truly stretches on forever, then matter configurations must eventually repeat, leading to identical or near-identical copies of everything, including Earth's and even you, existing far away. A multiverse provides a neat, easy way to accommodate this need for repetition. While direct observation is impossible, scientists are actively exploring potential indirect evidence. Anomalies in the cosmic microwave background, CMB, could be signatures of collisions between bubble universes, and particle colliders might reveal signatures of extra dimensions or parallel branes. Of course, the multiverse isn't without its critics. The most prominent criticism is the lack of direct empirical evidence and falsifiability. Alternate universes currently remain beyond our technological capabilities for direct observation. Critics argue that the concept lacks empirical evidence and falls outside the realm of testable hypotheses, making it more speculative than grounded in empirical observation. If a theory cannot, in principle, be proven false, some argue it falls outside the domain of empirical science. Another significant objection is that the multiverse theory appears to violate Occam's razor, which states that the simplest explanation is usually the best. Critics argue that embracing the multiverse requires accepting a host of other notions, including other universes, inflaton fields, tiny strings of energy, hidden spatial dimensions, gravitons, and more, an unnecessary complication. Some also argue that the multiverse does not truly solve the origin problem, but merely displaces it, as the mechanisms that create multiverses would themselves require prior unexplained fine-tuning. Finally, the credibility of some multiverse models is challenged by the failed predictions of related theories, such as certain inflationary models or supersymmetry, which have not found empirical support in experiments. Beyond physics, the multiverse sparks profound philosophical questions. At its core, it fundamentally challenges our traditional understanding of the universe as a singular entity, raising profound questions about the nature of reality, causality, and our place in the cosmos. It also fuels debates on free will versus determinism. If every possible outcome of a choice or event occurs in some universe, does this undermine the concept of free will? Some philosophers and physicists argue that free will can still exist within the framework of quantum probabilities, emphasizing that while all outcomes exist, our conscious experience is confined to a single path where our choices still matter. A particularly vivid, albeit highly speculative philosophical implication is the concept of quantum immortality, which posits that if MWI is true, your consciousness would seamlessly shift to a different reality where you survive any potentially fatal event, making you subjectively immortal. However, even proponents acknowledge that this is more than likely not true, as it cannot account for physical decay and aging. The concept of the multiverse has transcended theoretical physics and exploded into mainstream popular culture, from blockbuster movies to television series, comics, and video games. While often simplified or dramatized, this widespread presence has made the idea familiar to a global audience, sparking immense public interest. Hollywood often takes creative liberties, but this cultural embrace can serve as a powerful entry point for viewers to engage with more rigorous scientific discussions. In conclusion, the multiverse theory, with its diverse and mind-bending propositions, remains one of the most compelling and actively debated concepts in modern physics. It stands as a compelling hypothesis and a serious and scientifically investigable possibility, yet it is crucial to acknowledge that it is still speculative due to the inherent lack of direct empirical evidence. Science is an ongoing process of discovery, And the multiverse represents a frontier of knowledge where physicists continue to explore its profound implications and diligently search for indirect evidence. Ultimately, the multiverse invites us to ponder the sheer wonder and vastness of reality. Whether approached as a topic of scientific inquiry, philosophical contemplation, or creative inspiration, the multiverse theory invites us to embrace the vastness of possibility and the wonders of the unknown.